With really one very narrow exception, we are not using large language models that you've heard of and just like large language models, period. So like we can't answer that question with like, Sonnet 4.5 or, DeepSeek 2, right? Like when we train a model, we are feeding it transaction data, and the goal of the model is to learn something about that wallet or that token in terms of what it's going to do. And language models can't do that. They just functionally and practically cannot predict a wallet behavior, predict a network state. They're not built for that. So every model that we built is actually completely in-house, generally trained on network data itself. And that's a core problem that I think you joined after we started talking about it, but that's a core problem that we see as solvable if we were to build something like a large blockchain model. So a particular family of language models really lends itself well to transaction data because you can kind of draw an analogy and say, all right, language has words and it has sentences. Well, blockchains they have transactions and they have blocks, and in many ways, those things share similar properties. So huge but very common misconception is that like we're picking up GPT 5.2 and we're using that somewhere. We do use one of the llamas models in Hoku's deep leap search function. So that's where you can ask a question like, all right, find me meme coin traders that consistently make big profits by buying meme coins early. And that language model converts that sentence, that query, into SQL code that then hits our database and returns a list of wallets. But that is really the only example where we are using an off-the-shelf language model